Hello everyone, welcome back to another exciting chemistry video lesson by Adrenaline the Bazooka Prophet, CEO Adrenaline online tutorial platform, a platform that has helped a lot of students master chemistry and becoming an expert in it. In our today chemistry lessons, we are going to be diving into the calculations involved under the standard heat of formation. Now, before we go into the breakdown of these calculations involved, we should understand what we mean by the standard heat of formation. Now, the standard heat of formation is the amount of heat evolved or absorbed when 1 mole of a compound is formed from its elements. Now we should understand that the standard heat of formation of an element in its pure form is equal to 0, meaning you only have the standard heat of formation of compounds. Is that all right? Now we should understand the rudiment. A lot of students have lost marks or have lost confidence in this aspect of this calculation because they do not understand the basics involved or the formulas that are involved and how to use them correctly. Now, in this video, we're going to be going into it step by step. Now, I will solve the first aspect for you, and then in the second question, you will solve it yourself. So you have to listen and listen good. Now, look at how easy I break it down for you. Be relaxed. Very easy. Yes, actually it is easy. Now we go. The question says, calculate the heat of reaction, right, which is delta H, for the following reaction. As you can see right here on the board, this is 2 molecules of water. When it breaks down, it will give me hydrogen peroxide and hydrogen gas is released. Given that the heat of formation of water is negative 286.67 kilojoule per mole, and again the standard heat of formation of hydrogen peroxide is equal to negative 188 kilojoule per mole. It is actually very simple. So let us see how we can go about it as we solve it together. Now we solve it. Question 1. The first step is we'll bring out the equation, which is 2H2O will give me H2O2 plus H2. Is that clear now? Now, if you bring out what you are giving, you were given the standard heat of formation of water to be what now? Negative 286.67 kilojoule per mole. That of hydrogen peroxide was negative 188 kilojoule per mole. Now take note, I have told you already that the standard heat of formation of an element in its pure form or pure state is 0. That is why you were not given that of hydrogen. It is what now? 0. Is that all right now? Now, what is the formula of the standard heat of reaction in this calculation? You have to know it. It is standard heat of formation is equal to the summation of the enthalpy of the product minus the summation of the enthalpy of the reactant. Simple, right? So it means the product minus what now? The reactant. The product minus the reactant. Very simple. So what do we do here? It is now equal to the summation of the enthalpy of the product, which is this one. Remember, it is product minus the reactant. What do we have here for the enthalpy of the product here? We have it to be, I put it in bracket, minus 1 188. Is that correct now? Take note. Minus 188 minus, put bracket again. The summation of the enthalpy of the reactant here is this not the reactant here? H2O here is the reactant here. Now take note. This is where a lot of students makes mistakes at. You were given 2 mole of water. So and you were only given the standard heat of formation, of this water here to be this, right? So what do? Please take note. The mole always affects it. Here was just 1 mole. 1 times this will give me this. That was why I didn't do it. But in this case here now, I had to 2 multiplied by, okay, 2 multiplied by negative 286.67. Okay, so quickly I will have to rub this top here to create more space. So what do? Take note, it will now be equal to negative 188 minus bracket 2 multiplied by negative 286.7. So when we do it, this is what we are to get. Okay, use our calculator. That is 2 multiplied by 286.67, which will give me negative 57.34, right? Now take note. Here become negative 188 minus times minus is plus. So here is 573.34, which is now equal to, what do? So that's 573.34 minus 188. The final answer is 385.34 kilojoule per mole. Kilojoule per mole. Take note, these are the steps. You were given that of the product here, which is H2O2 here, to be negative 188, because here is 1 mole. That is why I just put it here. If here was 2 mole, it would have been 2 multiplied by this, but you only have 1 mole here. Simple. So here is just 1 multiplied by this will give me this. Now, for water here, you have this, but you have 2 more of water. So it will be 2 multiplied by this here, which we did there, and it gave me this. So I just minus times minus will give me plus, and that is how I got this answer here to be this. Now, in this number 2 here, you will help me to do this number 2, right? It is the product minus the reactant, and all of them is just 1 mole. So this minus summation of these 2, of course, you should get your final answer. And this marks the end of this first episode of the calculations involved in the standard heat of formation. Sit back, do well to subscribe, tell me your comment and the answer to this number 2 question. These are JAMB questions. Now, watch out for the next episode. Thank you and God bless you.